Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN bin ANUAR, and today I will be presenting the question 1 of the operational research assignment. For the table of content, the first one is define transportation model, followed by purpose of transportation model, tableau format, initial feasible solution determination methods, which is northwest method, solution of transportation problem, optimal solution, and conclusion. For the first one, which is introduction, defining transportation model. Transportation model is a special class of linear programming that deals with shipping a commodity from sources, for example factories, to destination such as warehouse. The objective is to determine the shipping schedule that minimize the total shipping cost while satisfying supply and demand limit. In a transportation model, sources and destinations are present. The next one is purpose of transportation model. The transportation model is concerned with selecting the routes between supply and demand point in order to minimize cost of transportation subject to constraint of supply at any supply point and demand at any demand point.
Hi, my name is MOHAMMAD ZIKRI. So I'm going to explain about tableau format. Manual solutions to transportation issues are presented in tableau format. The amount assigned from a source to its destination is represented by each cell in a transportation tableau as a decision variable. Rim values are the supply and demand values that run along a tableau outer rim. So if you want to see whether the transportation cost is balanced or unbalanced, the total supply equals to total demand is balanced transportation cost. Meanwhile, unbalanced if total supply is not equal to total demand. For initial feasible solution determination methods, transportation model must be provided an initial feasible solution rather than starting at the origin when all choice values are 0. Initial techniques for determining a feasible solutions include the northwest corner strategy, minimum cell cost approach, the Vogel approximation technique. In the northwest corner approach, the tableau top left-hand corner cell receives the greatest allocation possible, followed by allocations to nearby feasible. So as you can see in the pictures, northwest corner is positioned at left-hand topmost corner. Next is step for calculating northwest corner method. The first step is find the northwest corner cell at the transportation tableau, allocate as much as possible to the selected cell, and adjust the associated amount of supply and demand by subtracting the allocated amount. Next step is cross out the row or column with 0 supply or demand. If both row and a column have a 0, cross out randomly row or column. Step 3. If one cell is left uncrossed, cross out the cell and stop. Otherwise, go to step 1 back. This is an example where the tableau format is finished completely. The transportation cost is computed by evaluating the objective function. When all rim criteria are met, the first solution is finished. As you can see, there are the columns who the supply and demand is already used up. We must cross the column and row. So now we are going to answer question 1 by using northwest corner method. Starting from northwest corner, we allocate 12 units to factory 1, warehouse 1. Thus, the supply from factory 1 becomes 28, which is 40 supply minus 12 demand. The demand for the first column is then satisfied. Cross out other column under warehouse 1 because the demand already becomes 0. Next, you can see in the red number, it symbolizes the next process by using the same method as stated before. So by proceeding with the same method, we observe that factory 1 warehouse 2 equals to 15, factory 1 warehouse 3 equals to 13, factory 2 warehouse 3 equals to 7, factory 2 warehouse 4 equals to 3, factory 3 warehouse 4 equals to 12, factory 3 warehouse 5 equals to 8, factory 4 warehouse 5 equals to 10. An initial basic feasible solution is exhibited in the left side.
The next one is the optimal solution. The optimal solution for this question is Z equal to 12 times 13 plus 15 times 9 plus 13 times 15 plus 7 times 12 plus 3 times 12 plus 12 times 12 plus 8 times 9 and plus 10 times 10, which is the answer will be 922. So the optimal solution for northwest corner is 922.
So for the conclusion, northwest corner method helps us in finding the shipment plan that reduces overall transportation costs while meeting supply and demand limit. Thank you.
Hi and Assalamualaikum. Welcome to our presentation on project network diagram in project management. My name is Muhammad Daniel bin Yusuf, ID number 572121210077, and my colleague Muhammad KHAIRUL AZMI will also be joining me in presenting today. Our goal for this presentation is to provide a clear understanding of what project network diagram are, how they are used in project management, and the benefit they offer. We hope that by the end of this presentation, you will have a better understanding of how to use project network diagram in your own project. Without further ado, let's get started. Today, we will be discussing the following topic: defining a network diagram, the purpose of a network diagram, the method activity on the node AON, identifying the early start ES, early finish EF, late start LS, and late finish LF using forward pass and backward pass calculation, identifying the critical path, identifying slack time, and last but not least, the conclusion. Let's begin by introducing the concept of project network diagram. A project network diagram is a visual representation of the sequence in which a project work can be completed. It shows the various activities and their duration in order to create a clear picture of the project. The diagram provides important information such as the earliest time that work can start on each activity and the expected completion date for the entire project. Network diagrams are a useful tool for project planning, implementation, and control. They provide a clear graphical representation of the relationship between project activities. When planning a project, a network diagram can be used to visualize the different activities and how they are connected. This can help to identify deficiency and potential bottleneck and allow for more efficient scheduling of work. During implementation, a network diagram can be used to track the progress of each activity. As the project file is updated with activity status and estimate the completion data, the network diagram will be automatically updated. This can be useful for tracking the overall progress of the project and identifying any issues that may need to be addressed. Finally, network diagram can also be used for project control. While the updated diagram will retain the status of all activities, the Gantt chart may be the most effective graphical report for controlling project work. By comparing their planned schedule to the actual progress, it is possible to identify any deviation and take corrective action as needed. A network diagram is a visual representation of a project schedule that shows the tasks, deficiencies, and duration of a project. There are two main types of network diagram: the precedence diagram method (PDM) and the arrow diagram method (ADM). The precedence diagram method (PDM) is a graphical representation of the logical relationship between tasks in a project. It uses box and nodes to represent tasks and arrow to show the deficiencies between them. The PDM is also known as the activity on node (AON) because it shows the activity as nodes and the deficiency as arrow connecting the nodes. The arrow diagram method (ADM) is another type of network diagram that is used to represent the logical relationship between tasks in a project. It uses arrow to represent tasks and nodes to show the deficiencies between them. The ADM is also known as the activity on arrow (AOA) because it shows the activities as arrow and the deficiency as nodes. The key difference between the PDM and ADM is the way they represent the tasks and deficiency. The PDM uses box and nodes to represent tasks and arrow to show deficiency, while the ADM uses arrow to represent tasks and nodes to show deficiency. Another difference is the way the two methods handle duration. In the PDM, duration are usually assigned to the task, while ADM duration are assigned to deficiency between tasks. Overall, both the PDM and ADM are useful for representing the logical relationship between tasks in a project that can help project manager to plan and schedule their project more effectively. Moving into identifying the network diagram. Basic unit of analysis in a network diagram is the activity, which is task or work element that takes place during the project. Activities may be linked by deficiency, which show the relationship between the task and the order in which they must be completed. Hello again and welcome to this tutorial on how to find the critical path of a project using the arrow diagram method. In this method, the activity code is labeled with letter A through N. The duration of each task is indicated by a number. The start and the end of each task is indicated by a start and a finish box respectively. To find the critical path of the project, we will first need to determine the early start, early finish, late start and late finish for each task. To do this, we will follow the step outlined by my friend Muhammad KHAIRUL AZMI. Once we have determined the ES, EF, LS and LF for each task, we can then use this information to find the critical path of the project. Thank you for joining us for this tutorial on how to find the critical path of a project and determine their ES, EF, LS and LF later.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad KHAIRUL AZMI bin KAMARUDIN. Next, we focus on our questions. Based on the question is to find critical path for each activity network. Find yearly start, yearly finish, late start and late finish. The method of this question is activity on the node AON. To solve this question, it have 4 steps. Firstly, steps 1 is construct diagram. We construct the diagram based on the question given. Step 2 is find critical path. Critical path is an effective way to analyze complex project. It represents the critical set of activities to complete a project and help to focus on essential activities which are critical to run the project. Critical path is the longest path on network diagram and the most important part. Also, any delay on critical path will lead to delay the project. Let's identify the critical path for the above diagram. It have 6 critical value. Firstly, ABCIJLN is 42, ABCIJKN is 41, ABCEFJLN is 44, ABCEFJKN is 43, ABCEHM is 31, ABCDGHM is 40. The answer is the critical path for above network diagram is ABCEFJL and N because the duration value is the longest, which is 44. Next is step 3, identifying yearly start, yearly finish, late start and late finish. To determine the duration of the project and identify the critical path, we need to calculate the yearly start, yearly finish, late start and late finish of each activity. To do this, we use a forward pass calculation and a backward pass calculation. For forward pass calculation, start with the first activity and assign it an yearly start of 0. Calculate the yearly finish of each activity using the following formula: yearly finish equal to yearly start and duration. Use the yearly finish of each activity to calculate the yearly start of the next activity. Repeat until all activities have been calculated. We look to the example. Duration of task A is 2. Yearly start of task A is 0. By using the formula yearly finish equal to yearly start plus duration, thus 0 plus 2 equal to 2. So, the yearly finish for task A is 2. For backward pass calculation, start at the end of the project. Calculate the late start and late finish of each activity using the following formula. Late start equal to late finish minus duration. Repeat until all activities have been calculated. We look to the example. Duration of task N is 6. Late finish of task N is 44. By using the formula late start equal to late finish minus duration, thus 44 minus 6 equal to 38. So, the late start for task N is 38. Now, we go through to the whole diagram. Firstly, we calculate forwards from start following arrows. Yearly start on initial task is 0. Yearly start for task A is 0. Move to the duration, task B is 4 and the yearly start is 2. By using the formula yearly finish equal to duration plus yearly start, thus 4 plus 2 equal to 6. So, yearly finish for task B is 6. Next, move to task J. It have 2 choice of yearly finish to be yearly start for task J is 23 of task I and 25 of task F. Yearly start is largest of immediately preceding yearly finish figures. Thus, 25 is largest than 23. So, we must choose 25 of task F to be yearly start for task G because 25 largest than 23. Secondly, we calculate backwards from end going against arrow. Late finish for task just before end of project is equal to earliest completion time. Move to the task C, late start equal late finish minus duration. Thus, 6 equal 16 minus 10. It is because late finish of task C is 16 minus duration of task C is 10. And get the late start of task C is 6. Next, move to the task C again. Late finish is smallest of immediately following late start figures. Thus, 16 is the smallest of 20, 18, and 16. Lastly, step 4, identifying slack time. Slack time is the amount of time an activity can be delayed without affecting the overall project schedule. To determine the slack time for an activity, we subtract its yearly start from its late start. Late start minus yearly start equal slack time. Or we can use late finish minus yearly finish equal slack time. Based on the diagram, slack time for task A, B, C, E, F, G, L, and finish are 0, while slack time for task D, G, H, I, K, and M are 4, 4, 4, 2, 1, and 4. In conclusion, project network diagrams are a valuable tool for project managers as they help to identify the critical path and determine the slack time for each activity. By using this information, project managers can better coordinate the activities of a project and ensure that it is completed on time. That's all from question 2. Thank you.
Assalamualaikum. My name is Muhammad FAIZ HADIF with my groupmate Muhammad IKHRAM bin Muhammad RIDZUAN. So we will discuss about question 3 of project 4, which is linear programming. The question is a manufacturer makes 2 types of toys, A and B. 3 machines are needed for this purpose. Each machine is available for maximum 6 hours per day operation. If the profit on each toy of type A is RM7.50 and type B is RM5, we need to show that 15 toys of type A and 30 of type B should be manufactured in a day to get maximum profit. So this table we will let the X and Y toys type A and B respectively. So the X represent type A toys and Y represent type B toys. So this is the equation that we have.
So next we start with putting the maximum profit equation, which is Z equals to 7.50x plus 5y. Then we set the equation for the graph. So first is 2x plus y less than equal to 60. This is derived from the first equation, which is, you can see from the table, 12x plus 6y less than equal to 360. Then the next is x less than equal to 20. This is also derived from the table. And for the bottom one is 2x plus 3y less than equals to 120. This constraint is to be put in the graph later when you see the last point, which is the corner point of the feasible region. This is when we put the x and y unknown into 0. So as you can see from the graph, for the first graph is, you can see A 20, 0. This is the start of the graph. C 20, 0. Then B 20, 20. C 15, 30. D is 0, 40. So we start from 0. This one is 0, O, 0, A, B, C, and D. So it will make a region here like this, and go next. So the last point is the value of Z at these corner points are as follows. So this is the point we get: A 20, B 2020, C 1530, D 040. So for the maximum value, we just put X and Y into the maximum equation. So 20x 0y put into Z equals to 7.50x plus 5y, we get 150. Then the next point is 2020, we get 250. C 1530, 15x 30y, we got 262.5. And for D 040, we get 200. So from the problem, we got the maximum value of Z is 262.5 at 1530. Thus, the conclusion of the question of the problem is the manufacturer should manufacture 15 toys of type A and 30 toys of type B to maximize the profit. That's all from us. Thank you.